Okay, this is a quick video to talk through two potential areas of confusion that I could foresee on the practice proofwriting where you were filling in the blanks. So the first one came up right here on this first question, and a lot of people for statement 3 were rewriting exactly what we had for statement 4. And we don't ever want to write the same thing twice in a proof. That's just redundant and unnecessary. So the thing that I was looking for in statement 3, and your clue was, if you're going to use the definition of vertical angles, that does not say that angles are congruent to each other. We've talked about that. It's a non-reversible statement, so it's not true as a biconditional. If two angles are congruent, then they're not necessarily vertical angles. So, therefore, the definition of vertical angles, much like the definition of a linear pair, just allows us to recognize it from a picture. So, if I'm going to use the definition of vertical angles, all I'm doing is stating that the two angles are vertical inwards. I consider statement 3 to be optional. If you're writing a proof on your own, you can skip that and go right to saying the angles are congruent by vertical angles theorem. What I notice is some students forget to not use the definition, and therefore by using it and stating that you have vertical angles, it allows them to then correctly use a theorem to state the angles are congruent, and they're more successful that way. So that's going to be something that you're going to need to decide. Again, if you want to leave statement 3 out when you're constructing your own proofs, I'm totally okay with that, and you could jump right to statement 4. Okay, what you can't do is say angle ABD is congruent to angle FBE by definition of vertical angles. Proof 2 I liked because we made use of our midpoint theorem, so just take a look at that and see if you caught that. Not the definition of midpoint, but the midpoint theorem. That's something we proved and we haven't really had the opportunity to use. Okay, I'm on the back side, and this one has the same thing happening here where I stated the angles are vertical. Again, optional step there. But just if you got messed up on the one, you probably got messed up on the other. And the other thing that I wanted to point out, you're going to do some looking at this by yourself, but if you did try this one, I think this was proof number 5. Quite possible, and this might have come up somewhere else, but I'm noticing here that you got confused by statement 4. Okay, we should be able to recognize that that's the reflexive property, saying something's equal to itself. So I'm guessing you were fine to say that. But if you're actually trying to follow the logic here, you might be questioning, like, why am I stating that? And that's a fair question. So there is a sort of a school of thought of, if I'm going to add or subtract something from both sides, my addition property, my subtraction property tells me I'm allowed to do that as long as what I'm adding or subtracting is equal. And if we're subtracting 5 from both sides, we all know that 5 is equal to 5. But if we're subtracting AK from both sides, which is what we're subtracting, because we don't really know what AK is, it's this unknown length, it's kind of nice to state, hey, AK is equal to AK. Therefore, I'm okay to subtract it from both sides and end up with step 5, moving from step 3 to 5. So, again, I'm going to consider this an optional step here. Step 4, you don't have to put that when you're constructing your own proofs. There are other places that we're going to need to use the reflexive property for a specific reason, and we won't be able to skip it. Here, it's kind of an optional. Okay, so hopefully that helps to clarify. Take a good look at what you did and mark any questions you have so you can ask me later.